we've been given a function and we want to determine if this function is even or odd. In order to make that decision, you're going to replace every x in the equation with negative x and simplify. If after you simplify, it looks exactly like the original function, then you have an even function. If after you simplify, it looks like -1 multiplied by our original function, then it's going to be odd. Okay, so I'm going to start off with, instead of replacing every x with a negative x, I want to look at what is it going to look like at the end. So if it's odd, if I take -1 and I multiply -1 times the original, distribute the -1 through, and I get this. Now the original function is this. So let's replace every x in the original with negative x. So here's my original function, -2x to the 4th plus 3x squared. Turn every x in the original into a negative x. Now we want to simplify, and I expanded just to help you see the simplification. I have 1, 2, 3, 4, 5, an odd amount of negatives. So I'm going to have a negative, and then 2x to the 4th. And then here, 1, 2 negatives, even amount of negatives, so positive. So I end up with -2x to the 4th plus 3x squared. And notice this looks exactly like the original. So this function here is even. Okay, so let's look at a couple more. I want to know if this one's even or odd. Now, if it's even, it's going to look exactly like the original after I simplify. If it's odd, it's going to look like the original multiplied by -1. So let's take the original, -2x cubed plus 3x, and multiply by -1. All I have to do is distribute that negative through, changing that to a positive and that to a negative. Okay, so now let's actually go in and replace every x in the equation with a negative x. So -2x cubed plus 3x, turning those x's into negative x's. Then let's simplify. When I simplify, I have 1, 2, 3, 4 negatives. That's an even, so it's a positive 2x to the 3rd. And then I have 1 negative, so odd amount, so it's negative minus 3x. And then let's compare that. Does the simplified version, which one does it look like? And it looks like -1 multiplied by the original, which means that this function is odd, symmetrical to the origin. This other one is symmetrical to the y-axis. Okay, so last example here. If this ends up being odd, it would be the original times -1. So if I distributed -1, that looks like -4x squared minus, whoops, let's take that off, my bad, minus 6x. And if it's even, it's going to look exactly like the original. So we'll go in and replace every x in the equation with negative x. So let's pop in negative x there. Do some simplifying. And we have 1, 2, 2 negative, so even amount, it's positive, 4x squared. 1 negative, so it's a negative, minus 6x. And then what does it look like? Well, this one's a positive, that one's a positive, so maybe it's this one, but see how it's not matching the original? This one is not the original, and it's not -1 times the original. So this function is neither even or odd. Quick sidebar, odd means symmetrical to the origin, and even means symmetrical to the y-axis.